Hi there, in this video we're gonna continue with section 1.4 and I want to just do a couple of examples of rationalizing the denominator. So rationalizing means usually you have a radical in the denominator and you want to get rid of it. If it said rationalizing the numerator, that could mean you have a radical in the numerator, and so but the rationalizing part means you have an irrational number, a radical, right, like the square root of 2, the square root of 7, and you want to make it a rational number. And so, for example, we're going to start with 2 over the square root of 7. So the square root of 7 is an irrational number. So we want to rationalize it, meaning make it a rational number. So one way to get rid of the square root of 7 is we're going to multiply by a funny looking 1. We're going to multiply by the square root of 7, top and bottom. So notice that this is equal to 1, so I'm not changing the value of that radical, but the reason I can do this is because if I do the square root of 7 times the square root of 7, I get the square root of 49. You see the property of radicals that we can multiply the insides, and the square root of 49 is 7. Some of you may think of this as the square root of 7 squared, which is 7, and some of you could think of this as the square root of 7 squared. There are different ways using the properties of radicals that this works. Either way, when you multiply the radical by itself, you get 7 when it's a square root. If it's a cube root, you will have to do it 3 times, right? So in this case, we're going to have on the top 2 times the square root of 7 over 7. And now the denominator is rationalized. This is now a rational number. Some of the ones that are giving you guys more of a problem are, what about when you have something like 3 plus the square root of 7? And now this is a little more complicated, and I'm just going to do an example of what not to do. And you'll see why. So what not to do is, notice that if I say 1 over 3 plus the square root of 7, if I just say times, as I did before, times the square root of 7 over the square root of 7, I'm not going to be able to solve it because this gives me square root of 7 on the top, but on the bottom I have to, this is a quantity, so I have to distribute. So it'll be 3 square root of 7, and then that one will become 7, but now I've introduced a radical in the other term, so we don't want to do that. So this is an example of what not to do. So if you're doing that, that may be why things are not working. So what we instead want to do is we want to multiply by the conjugate. And the conjugate of something like this is you change the middle sign. So the conjugate will be 3 minus the square root of 7. And so what I'm going to get is 1 over 3 plus root 7. And we're going to multiply by the conjugate. So top and bottom, 3. And now, as I simplify, I'm going to have on the numerator 3 minus root 7. And in the denominator, I have to FOIL this. But the reason we multiply by the conjugate is because middle terms go away, right? If I have 3 square root of 7 times 3 minus root 7, notice that I'm going to have the first, 3 times 3 is 9. The outer is minus 3 root 7. And then the inner plus 3 root 7 and minus the last. Square root of 7 times square root of 7 is 7. And so notice that our middle terms go away, which is what we want. So here we're going to have, once I multiply this, I'm going to get 9 minus 7, which is 2, which is a rational number. So I get 3 minus the square root of 7 over 2. So we started with an irrational number in the denominator, and now we turn it into a rational number. And so that's what it means to rationalize. So let's try a third example. So if I have 10 over the square root of 7 minus the square root of 2. It's coincidence that I'm using the square root of 7. It's not my favorite number if you're thinking that. So here, how do I solve something like this? Well, we're going to use the same trick as above. I have a plus or a minus in radicals, so that means I have to multiply by the conjugate. The conjugate is the square root of 7 plus the square root of 2. Right, so then in the numerator, I'm going to get 10 times the quantity, square root of 7 plus the square root of 2, over, and now I do this. Now remember that the middle terms are still going to cancel, which is why we multiply by the conjugate. So I'm going to just get the square root of 7 times the square root of 7, which is 7. Middle terms cancel, so I don't need to worry about them. So I get just the first and the last. The square root of 2 times the square root of 2 is 2. So I will just get this. So I'm going to have 10 square root of 7 plus the square root of 2 all over 5. And notice that before I distribute this 10, I can actually reduce it with that 5. Since this is multiplication over here, I can say 10 divided by 5 is 2. So my final answer will be 2 times the quantity square root of 7 plus the square root of 2. And you could leave it like that, because that will be fully simplified, but some people may choose to distribute. Now when you distribute, make sure that you're multiplying by the coefficients. There's a 1, invisible ones over here, so you will see 2 times the square root of 7 plus 2 times the square root of 2. So that could be another way you can write your answer. Be careful not to say the square root of 14 and the square root of 4, because you cannot multiply something